Hey all, Mousseau here. Let's talk about static electricity, also known as electrostatics. So y'all know what static electricity is. Everyone's always interacted with static electricity many times in their life. Walking around your house, getting a little bit of a static discharge, a little shock, a little wowzer. The concept isn't crazy, and it's certainly not anything new. However, the physics behind it, and I think the true understanding of everything it kind of means and where it comes from and how it was even understood, is a little bit more vague. Yeah, I'm sure many of you have built misconceptions dealing with this very own concept throughout your entire life. So we're going to address that and more throughout this series of videos. So electrostatics is part of the beginning of a larger unit of electromagnetism within physics. It's one of the fundamental forces in nature. We're going to discuss that later. And it is the first stages in which we take a path to a deeper understanding of electricity. So we're going to begin in this particular topic covering electric charge, electric forces, field, and other topics such as electric potential and energy. And we're going to eventually then move ourselves into the overall concept of electricity, circuits, and much more. So let's cover this in a little bit more depth, but not too deep quite yet. So let's get to the basics. Some of those most basic characteristics of static electricity are where we discuss how charges interact with each other. And we have developed a series of very basic principles in which we describe this. So we have two types of charge. You have positive charges and negative charges. And you can see in this diagram up here, we've got various different interactions of these types of charge, with the plus symbol indicating the positive charge and of course the minus symbol being the negative. Now, as we've observed, we know that like charges, positive and positive or negative and negative, they'll repel each other. Whereas unlike charges or opposites, they're going to attract each other. So a positive and a negative charge will go towards each other or attract each other. And so this is an observation of a force. And this force itself is a force that is a non-contact force. The charges do not need to be touching each other. There exists a field between them that allows them to interact. This is actually only the second force that we have discussed in this whole series of physics videos dealing with a non-contact value. So that means there's going to be a field surrounding it. Of course, the other force that we discussed was the gravitation force, in which we also incorporated the idea of a gravitational field. We're going to discuss that very same concept with electricity. Of course, it is important to understand how charges within nature distribute themselves at the most basic level. So let's discuss this whole model of an atom down here. We're going to use a relatively elementary description of the model of the atom. This certainly isn't perfect, but it gets the idea across. And what we're showing here is that we have a nucleus, this little part here in the middle, that contains subatomic particles. Those particles will be specifically the protons and the neutrons. Your protons are the positively charged objects, and neutrons are neutrals. So we're not really going to discuss neutrons a whole lot in this series. And then surrounding that nucleus, in more or less in orbits, not quite, but in orbits, are electrons. And those are going to be negatively charged. And so anything that is going to exist in nature kind of all on its own is going to be neutral. We're going to have an equal quantity of negative charge as we have of positive charge to make the overall structure of that object neutral. However, if we can get a distribution of that charge, if we can, change that balance a little bit, that's when we're going to start getting some interactions amongst those particles. Getting down to a little bit more detail here, we want to talk about how that negative and positive interaction of charge, or those values, their magnitude or their size, their value, are actually going to be identical. But of course, depending on their sign, whether it's negative or positive, the direction of that particular field that eventually creates will be opposite. So we will define electrons as negative sign and protons with positive sign. What's really important is the second bullet. Really make sure you focus on this. This is ironclad. All charged objects in nature have to be integral multiples of a very basic quantity of charge. It means all charges, regardless of their value, have to be some combination of this most basic unit of charge. This is known as a fundamental value. Nothing can be smaller than that basic unit of charge. And that charge, we're going to define right down here, Q being the variable representing charge. Sub E, I'm going to talk about that in a bit, but it refers to elementary charge. It's equivalent to 1.6 times 10 to the negative 19 coulombs. A little bit of a typo here. I'll just cross that out. Now that charge, the unit for charge, is the coulomb, a capital C. Now that coulomb is named after a scientist that did some work on that. I'm going to discuss that a little bit later on in the section on Coulomb's law. But this is a very tiny value. 1.6 times 10 to the negative 19 coulombs is very, very tiny. In fact, it is the smallest charge something can have. Again, it's fundamental. Every other charge has to be some increment of this value. We often will represent Q as charge with the subscript E, which represents the elementary charge. Now, this is also very important to not mix up. A lot of students want to say E stands for electron. It does not. It stands for elementary charge. Remember, an elementary charge is 1.6 by 10 to the negative 19 coulombs. Now, this seems redundant. I have 1.6 by 10 to the negative 19 coulombs written twice. And it is redundant. It was kind of on purpose because you're going to see them both written in these different forms. You're either going to say Q sub E, the charge of one elementary particle, or E. It really means the same thing, elementary charge. Also, again, the coulomb is the basic unit of charge. Since we can represent one charge as 1.6 by 10 to the negative 19 coulombs, we can identify how many elementary charges fit in one whole coulomb. And so that's this value down here. 1 coulomb is equivalent to 1.625 by 10 to the 18 elementary charges. I do want to discuss this other concept one more time and just point out a few ideas here. This whole idea of everything being an integral multiple of that unit of charge. You're going to often come across problems in physics that will give you basically a word problem. They'll say something like yada 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 has a certain charge. Which of the following is a possible value of that charge, or which of the following is not possible? And you're usually going to be given a list of things that have various different numbers. And what you have to try to do is make sure those numbers is divisible by this number. So for example, you might be given a value of 2.2 by 10 to the negative 19 coulombs. Well, 2.2 is not an integral multiple of 1.6. Therefore, that value is not possible. However, 1.6 times 2 would work, so 3.2 times 10 to the negative 19 coulombs, or 4.8 by 10 to the negative 19 coulombs, and etc. Keep that in mind. It's got to be one entire integral of that number. Okay, so here are the basics of charge. We're going to kind of move into some other concepts coming up, but I think that'll cover it for this particular video. Thank you.